So today, Academic Daddy will be teaching you everything you need to know about functions. So let's say I have f of x is equals to x squared plus 2. Now, whenever you're dealing with function, basically, you need to understand this. When you're dealing with function, you're thinking of a mathematical machine that you use to analyze the level of input, what you can input for x. And when you think of inputs, we are talking about domain now, and the output you are expected to get. And when you talk about output, you mean range. Now, looking at this expression given to us, they are not telling us to solve anything when we are looking for domain. They are simply asking us, what are the possible values that if I put for this x, this value will still be defined? And you know that being defined means it can still work. When it says undefined, when you think of something to be undefined, it simply means that we are talking about instances like 1 over 0 or a number over 0. You know that this cannot work. We are thinking of instances where we have root minus 1 or root of a negative number. And you know that this cannot work because the root of any negative number is a complex number. So it's all undefined. So is there any possibility that, or is there any number that we can put here that when we input it, it will make this expression not to work? If you look at it very well, you see that it's not possible. Every value we put here can work. If you put 1 here, 1 square is 1 plus 2 is 3. 2 square, you work. If you put minus 10 here, it's going to be 100 plus 2. So any value you put in here will work. Any value you put in here will work. So for that reason, we say that the domain is simply minus infinity and positive infinity. So because of that, we say that the domain is minus infinity and positive infinity. We can put any number ranging from any number, it will work. In fact, you need to know that any linear expression you have, the domain is always this way. Now, what is the range? In the range, this is where you think of it, because as a mathematics student, once you see this kind of question, you want to solve. Now, remember I told you when we did differentiation that f of x is the same thing as y. So the f of x being y, this is now x squared plus 2. So whenever you want to find uh, the range, it simply means know that the only x we have here is this. Find the value of x. That means if you find the value of x, whatever you have at the possible output, you can put in there for x, because it will equal it, or it will be greater than or equal to it, or it will be not equal, depending. But when it's linear expression, it will be equal. So in this case, this f of x is the same thing as y. So make x subject of the formula, so that I have that this is the same thing as y minus 2 equals to x squared. Making a subject of the formula, I'll now have roots y minus 2. That is square crossing equality sign becomes this. So if you know this now, at this junction, this is the point where we now ask ourselves, what are the possible values we can put in here? What are the possible values we can put in here for y? What are the possible values we can put in here for y? Now notice something. Notice that if I choose to carry this y minus 2 outside now, y minus 2 outside, let's overlook x this time. Let's just check something. Notice that y here, y here cannot be less than 0, because if I have, for example, minus 1 here, this will be minus 1 minus 2, which is going to be minus 3, and square root of minus 3 means that this is a complex number. So for that reason, whenever it's a square root you have, square root you have, or cube root, know that this your value will change to inequality sign, so that this will be the y minus 2 greater than or equal to, it must be greater than or equals to 0. So if you know this, that means that, for example, if I have this y minus 2 this way, let's try to check it. So this means that this can be y, and when it's crossing this, it will be greater than or equals to 2. So that means that the range is going to, because if you put 2 here, 2 minus 2 is going to be 0, root 0, 0. That means greater than or equal to, so all those values greater than 2 and equal to 2. That means 3 minus 2, 1. 3 minus 2, 1. Root 1, 1. Now if I put, so note it, how I've done it now, this is how you do it. Once you've gotten this, you now use it to access. When you call it, you now use it. So once it's a square root that you have, you must always have greater than or equal to. So if I have this to be greater than or equal to, this can also mean 4. 4 here, 4 minus 2 is going to be 2. Square root of 2 will still give me a positive number. So that means that in the notation, there's what we call interval notation. For the interval notation of this, all I need to do is carry this is 2 I'm seeing here, carry 2 and put here. If I put this 2 here, it simply means that 2 is among, because it said greater than or equal to. Then greater than or equal to means any number above 2 and 2 included. Assuming 2 was not included, it will be open. So let's say this is positive infinity. So the range of values, interval notation, is simply 2 and infinity. This is bracket for it, then parenthesis open. Now this is the interval notation. So to write this, the range will simply be f of x. Remember that f of x means descending as y. F of x is descending as y. Remember that f of x is descending as y. So but we represent this as f of x greater than or equals to 2. You know that. So in range, this is going to be f of x greater than or equals to 2. This is our range. So let's move to question number 2. Now moving on to question number 2. This is to find the domain. I told you it means inputs. For domain, your mind should be on everything here. So for the upper value, for anywhere you see x, I know that for this x, values I can put for this x plus 1 is the same as if I put 1 here, this will be 1 plus 1 equals to 2. Any value I put here can work. So x can be equals to 1, or it can be equals to minus 1. So any value I put here, so this is the same as negative infinity up and positive infinity. Any value I put here will work. If I put minus 1 here, minus 1 plus 1 is 0. It will still work. 0 is allowed to be in the numerator. 0 is allowed to be in the numerator. It's okay, but 0 cannot be here. So they say all over. That is why anytime you see any number here and here, it's as if they always ignore the numerator, because it means that it can work. Where you focus to find the domain now is on the down parts, because you know that anything down here, this down part cannot be equal to, anything here cannot be equal to 0, because you cannot have 1 over 0, 3 over 0, 2 over 0. Once you have that, it's now non-defined, so it cannot be equals to 0. So if you know that, this simply means that 2, the same thing as saying 2 minus x not equals to 0. And you know that if this is not equals to 0, it means that if I have minus x this way, let me use it this way. If it's crossing over, because minus 2, this and this cancel, so that x is not equals to 2. So this is the domain. So if you check it, for example, let's say I put 2 here. If x was equals to 2, if I put 2 here, 2 minus 2 is now 0. And 0 cannot be at the denominator. So x cannot be equals to 2. So the domain of this is simply, using interval notation, the domain of this is simply come to this part, draw this. Now we know that the upper value, any number can work, anything at all both the negative infinity, both the positive infinity can work. Now we have that x here, we have this part not to be equals to 2, so that means that we are not including this, can never be 2, so that x simply means any value from negative infinity. And if that is the case, you know that 1 can be here. 2 minus 1 is 1, it's okay, it will work even down to 1.5 and the rest. So this is negative infinity, comma, let's now use down to 1, and this has to be closed, this has to be closed, this has to be closed, that is bracket union. Even anything above these two can still work, because if I put 3 here, sorry, if I put 3 here, 2 minus 3 is minus 1, and it can work, it is defined. So it is okay for negative number to be at the denominator. So this is now, I have 3, can have 2.5, is still okay, but let's just 3 comma positive infinity. So this is the interval notation. Now they say f of x is the sentence. Okay, I almost forgot. In the last question, we got the domain, we did not find the range. So to find the range is simply y equals to x plus 1 all over 2 minus x. And you know that this is the sentence saying 2 minus x all into y equals to x plus 1. And this is the sentence 2y minus xy equals to x plus 1. Now check this out. This is the sentence saying what can go here. Factoring this out, I have that this is the sentence. So factoring this out, I have that this is the sentence 2y into x times this 2y times this xy equals to x plus 1. And you know that this is the sentence. Continuing this is now the sentence. Everything here is now the sentence. It's not the sentence saying, you know, our goal is to make x subject of the formula. So doing that, we now have that this is the sentence saying, okay, I just showed you that it can be I just tried to show you that it can be factored out. So this is the sentence saying y minus 1 then equals to x then plus x1. That is, you see, 2y minus 1 crossing this way, then x. So this is the sentence saying divide both sides by, okay, when you see this way it has been arranged. Now this is the sentence saying, since I have x this way and I have plus xy, let me take it that this is going to be x plus xy then minus 2y minus 1 equals to 0. So that if you check it, this is now going to be the sentence x